Welcome to our tutorial for question 13 of our weekly review. Question 13 is going to show us some data on a graph, and we're being asked to determine the associations of that data. Another way to think about this, and a vocabulary term that sometimes is used, is what's called the line of best fit. When we're looking at these associations and this data, what we want to do is we want to see how this data is related to each other, if it is at all. In order to do that, we can ask ourselves a few questions. One, what trends do we see in the data? When we say what trends do we see in the data, we mean what type of predictions could we make based on the data that we see itself? If there are trends, we can start to make some predictions. And if there aren't trends, then it's probably not possible to make any predictions. We can also ask, does the data correlate? And another way to think about that is, does it create a pattern? When you think about the predictions that we just talked about in the last question, how accurate can those predictions be as we start to make those predictions? That's describing how our data correlates with itself. We're also going to ask the question, does it create a straight line? Because that will tell us whether or not our data is a linear or nonlinear relationship. And we want to know, is the correlation positive or negative? And I've simply drawn a positive and negative slope there to help us remember what that looks like. Finally, we can ask, how strong is the association or the correlation? Meaning, again, how accurate can that prediction that we make be about what future or past data points might look like in this particular set of data? Let's go ahead and look at some examples of some relationships of data, and we'll see how we can answer these questions with this information. Here we have a set of data, and you can see that this says that there is no correlation. And we would say that there's no correlation here because this data is pretty random. There is no pattern. There's not really any way for us to figure out what would come next or what came before it. You can see that contrasts with the data that's on the right, where we would say that's a high positive correlation. We would say that that's a high positive correlation because I could make a positive line that runs through that, and it's a high correlation because for the most part, that data is pretty close to the line. It's not all on the line, and it certainly all isn't the same distance from the line, but it's pretty close to the line. So there is a pattern. I could predict a future or past value, and the prediction for that future or past value is probably going to be pretty accurate because all of those data points so far are pretty close to that line. We could also look at a negative correlation, and this one would be a high correlation, and for similar reasons. It has a negative slope, but all of the points of data that are on this data set are relatively close to that line that we've created. Now we could also see things that we would call low correlation. If I look at this low correlation data, it's not quite random like the first example that we saw. We could probably make a prediction that the data tends to be going up in this. But if I look at that line, I'm going to notice that there's actually a lot of variation between how far those data points are from that line. That makes that low correlation. And that means that if I were to make a prediction, I don't really know how accurate my prediction is going to be. I can probably predict the general area that it will be in, but I can't necessarily predict with a real sense of accuracy what that next data point or past data point will be. The other thing with this is, although this looks positive, because it's a weak correlation, we might also be able to draw some other lines that you could theoretically see. So there I've drawn several lines that could also maybe even fit in this same data, and that would show us that this is a pretty low correlation. The more lines that you could theoretically draw, and in fact this one even shows a negative slope within that, the lower the correlation is going to be. And we could show that same thing for a negative correlation as well. Again, this is not the same as random. I could probably make a prediction about a future or past value. I can see that in general, it seems that I'm making a negative slope here, but that correlation is pretty weak because my predictions can't be perfect, and I also could probably start to think about some other lines that I could draw within that. All of these, or the 4 examples that at least have correlation here, are linear, and we would call them linear because they create a straight line. But you can also have data that is nonlinear, so let's take a look at some examples of those. Here's 5 different examples of some data that we might see. And it's important to note that in these cases, you certainly would not have to describe if it's positive or negative. We would simply say that they are nonlinear. We still could make trends and see patterns that are happening within this data. They just don't create a line or a straight line, and so we would call all of these examples of nonlinear data or nonlinear association. That should give you a sense of how we are going to think about and work with the association of our data that we have. And this becomes really useful when we are working with real-life data points that don't always match perfectly to a linear equation or a linear graph.